no deformation, no question of stress, no question of restoring force. So that is the idea. From there we start with today's ideas. And strain is ratio of, say, stress we learned, strain, and also we learned tensile stress and longitudinal strain. And there are two more. Before learning that, we learn one more thing. Stress and strain. Strain is, we have defined it as change in length by original length. But general definition is change in dimension. It may be area, it may be volume. That's why I write change in dimension. In our first case, it is change in length, this tensile strain or longitudinal strain. But it need not be always. That we see later on. Change in dimension by original dimension is general definition for the strain. Stress, you know. So with these things now, there's a beautiful saying in science or in day-to-day. They may ask you many times, hen is first or egg is first? Koli madla, motte madla. ಈ ಕ್ವಶನ್ಗೆ ಸ್ವಲ್ಪ ಆನ್ಸರ್ ಹೇಳೋದು ತುಂಬಾ ಜನಕ್ಕೆ ಕಷ್ಟ. But from the point of view of evolution, say we can think of how the evolution took ಅಂದ್ರೆ ಕೋಳಿ ಬರ್ಬೇಕಾದ್ರೆ ಮೊಟ್ಟೆಲೆಲ್ಲೋ ಒಂದ್ ಕಡೆ ಎವಲ್ಯೂಷನ್ ಫಸ್ಟ್ ಜನರೇಷನ್ ಕೋಳಿ ಏನ್ ಬಂತು ಮೊಟ್ಟೆಲಿ ಅದು ಕ್ರಿಯೇಟ್ ಆಗಿರ್ಬೇಕು. ಸೊ some biologists treat egg as first and then okay, genetic modification alaitu from hundreds of millions of years. That modification took slowly. When the first hen came, all that material is there in the egg. That's why they say egg is the first and then hen is second. Okay, whatever it may be the thing. Here is one such condition. Why I said that? That means which creates which. That's the idea. Say just now we said egg creates the egg. Like that. Here, the sun strain, which is more fundamental. Say you learned relations and functions today, you are going to write the test also. In relations and functions, if I write a function like this, y equals x is called as independent variable, y is called as dependent variable. You know, in high school also you learned it. This is dependent variable because it depends on the x. X is independent. As x value changes, y also changes. That's why we call y as independent variable, x as independent variable. In that sense, among stress and strain, which is more fundamental, on which one depends? Go for it. Among stress and strain, strain is fundamental. Only one is right there and remaining 4 or 3 are wrong. Why? That means we have not thought of it. What exactly the stress definition, strain definition? Can you think of the stress definition once again? It is the internal restoring force generated per unit area. When is the internal restoring force generated? When there is a strain, when there is a change, when there is a change in the shape. So what is first there? Change in the shape. Later on, restoring force is created. In a spring case also, if you don't pull, if there is no length increase in the spring, there is no question of spring force, restoring force. Therefore, strain is fundamental than stress. Okay, such mistakes are done by 90% of the class. Okay, let's not bother about it. Okay, we go for it now. So I write stress proportional to strain. Say what we write on the right hand side is more fundamental than the left hand side. Y equals x square, it is independent. Y is dependent, x is independent. In that manner, stress is dependent on strain, not strain depends on stress. Please correct that. Nothing to worry if you go wrong, because many think like that only. I'm asking you, stress proportional to strain. This was the law given by Hooke's law. We call it as Hooke's law. And stress proportional to strain. In fact, not only simple statement, only one thing to be added extra. Hooke's law states that this within the elastic limit, stress is proportional to strain. Within the elastic limit, stress is proportional to strain. What do we mean by within the elastic limit? Can we think of one thing? Beautiful idea. Say if you take a rubber band, go on pulling it, pull it. At some stage, what happens? It breaks. It breaks. If you take a spring, go on pulling it. If you take your ballpoint pen, spring action pen, spring, and go on pulling it. After some time, it elongates, it will not come back to its. So that is what we call as within the elastic limit. Within the elastic limit means once the deforming force is removed, it should come back to its original shape. That is possible up to certain stress. After that, it will not. After that, what will happen? It's going to change the shape permanently. So, what is the idea there? Now we want to learn that. Say, stress is proportional to strain within the elastic limit. For that, they have written a graph for that, generally for many material. Stress on y-axis, strain on x-axis. Observe, x is independent, so strain is put on the x-axis, independent variable. Dependent is on y, so y, like that. What is the curve here? We write down the curve. Just look at the curve now. The curve is like this, up to certain point, a straight line, starting from the origin if you want. After that, it takes a shape like this. There I call as B, and then C, 2 points there, and I take it slightly higher, and then say D here. This graph is important from the point of view of board exam also. Very, very important graph. And who is going to join for engineering? They all do this type of work in the first year itself. Whatever may be the most probably your elective, you are going to do this strength of materials or something like that. Okay, for the time being now. This is what we call as elastic curve for any object, say. And here, observe, I extend this stress axis slightly. Say, I marked 3 points in the beginning, A, B, C. A is called as proportionality limit. Within the elastic limit, just now I said. That is the meaning. Say, up to that stress proportional to strain, because it's a straight line. After that, it's not straight line. Therefore, it is proportionality limit up to A. A is called as proportionality limit. And what we call as B, B is called as yield point. Yield point. What do we mean by that? Can you think of something? Because you know the say word yield. Yield. Can you think of something? Yield point. Say when we see at old sofa sets, for a long time usage of the cushion there, that somewhat get deformed and its shape is somewhat changed. Like that, there are many such things. So yield point means this point where the shape change starts becoming permanent. Shape change is permanent, is going to be permanent. And also yield point means the stress and strain, say strain creates a stress, but it is not proportional and it is going to change the shape permanently, slightly. Shape change is permanent. That's why you call it as yield point, yielding. We say many times that person yielded to the pressure of money, pressure of politician. Yielded means to give away. Oh, I have used this word. Can you once again, actually once previously, where? Can you remember? Can you remember where we use this word? In one chapter, in one numerical, I can say. In one numerical. ಜ್ಞಾಪಕ ಇದೆಯಾ? ಅಷ್ಟು ಜ್ಞಾಪಕ ಇರಬೇಕು ಮಕ್ಕಳ. ಅಲ್ಲಿ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿರ್ಬೇಕು ನೀವು ಅಷ್ಟೊಂದು. Laws of motion ಅಲ್ಲಿ one wooden block is kept on a soft floor. Over that 25 kg cylinder is placed. The floor yields with steady. Observe those words to be remembered. Even today I can remember very special names of students who I taught right from my career beginning, say 1988, September 2nd. So not only that, some of my friends' names who are with me in 7th or 8th, till now I know, even though I'm not the close friend of them or something like that. Why? There are some special names. One of my friend name long back, the old village name, Puttadasa, that I can even today remember. And I remember I met him when I had gone to a trip to Chitradurga. Actually, it is his name. He was not with us. I have seen him on the road, and he waved his hand to us in our school bus. So like that, here also, why I'm saying is, yield is the word. Can you remember? We use that word only at that problem, nowhere else. This is the second time I'm using. That's why I said, who is going to think of what they learned after the class without disturbing their position? They definitely top their ranking list. It is the shortcut. Agbiಟ್ಟು ಬೇರೆ ಏನೂ ಇಲ್ಲ ಮಕ್ಕಳ. ಕ್ಲಾಸ್ ಮುಗಿದ ಮೇಲೆ ಆ ಜಾಗ ಬಿಟ್ಟು ಎದ್ದೋಗದೆ, ಹೊಟ್ಟೆ ಹಸ್ರು ಎದ್ದೋಗದೆ, ಮತ್ತೆ ಹೇಳ್ತಿರ್ತೀನಿ, ಬೇಜಾರು ಮಾಡ್ಕೋಬೇಡಿ. ಇಲ್ಲ ಎದ್ದು ಹೋಗ್ತಾ ತಲೆಯಲ್ಲಿ ಯಾವಾಗ ನಾವು ಇದನ್ನೇ ತುಂಬಿಕೊಂಡು ಯೋಚನೆ ಮಾಡ್ತಾ ಹೋಗ್ತೀವೋ ಯಾವತ್ತಿಗೂ ಮರೆಯಲ್ಲ ಮಕ್ಕಳ. ಯಾವತ್ತಿಗೂ ಆಗಲ್ಲ, ಮರೆಯೋದಕ್ಕೆ ಸಾಧ್ಯವೇ ಇಲ್ಲ. ನೀವು ಮರಿತೀವ್ರೆ ಮರೆಯಲ್ಲ. Okay, let it be that. Now, yield point means what? That is the point after which the shape change starts becoming permanent. The object will not come back to original shape. That's why we call it as yield point. It is yielding to the stress. So it is going to change the shape permanently. And then yield point corresponds to a stress there. We call it as sigma y. Sigma y. We call it as yield strength. Yield strength. Sigma y is the stress on at P, yield point, that is called as yield strength. Sigma y stands for yield. Sigma stands for yield strength. Then look at this point C. Point C is called as, say, B is yield point. Point C, observe, up to from point C onwards, shape change is permanent. That's why we take point C as permanent set limit. Permanent set. That means after that shape change goes on becoming permanent. Okay. Then we go to the point D there. Point D, we call that stress as sigma H there. Ultimate strength. Ultimate strength. That means from C to D, any change in the shape is permanent. Stress is not directly proportional to strain. Hooke's law is invalid. Even after A itself is Hooke's law is invalid. That's why we said Hooke's law, within the elastic limit, the change in shape, within the elastic limit, stress is proportional to strain, up to A only. Even at B, it's not proportional, but it can come back to its original shape after some time. But see, it's impossible. So that in this dotted line tells us permanent set region. Permanent set, in our book it is given around 1%. 1% permanent set only. After that, C to D, it's completely permanent set. Whatever may be the change in the shape, it goes on remaining as it is. At D, ultimate strength, the thing corresponds to ultimate strength. D to E region is called as fracture zone. It is not mentioned in our book, fracture zone, and E is called as fracture point. Fracture point. What do we mean by these things? Say, most all in high school chemistry or somewhere, you learn two words, ductility and brittleness. Ductile, have you heard of it? Brittle, opposite to ductile. Ductile and you can draw something into wire. Ductility, say copper tagoli, ishdappa cube ide, adan melt ಮಾಡಿ you can draw this into a wire. Any much bigger. Adu ductility. Brittle, malleable is sheet. Malleable, what is Aditya saying? Brittle can be broke easily. What is that? Can you give me? It's a nice thing. Can you give me an example? Glass is brittle. What do the glass? Glass is brittle. Brittle means it fractures fast. It breaks fast. Okay, nice. Look at the board now. So, D to E is fracture zone. For copper and such ductile materials, D to E is bigger, longer. For glass and them, D and E are almost coinciding. Pakdale irte graph alli. Ade copper, aluminum todre, they are far apart. Fracture zone tumba doddirutte, ashtu bega cut agalla. They can draw them comfortably long. So that is the idea of ductility and fracture. So with these ideas, this graph and these points are very important. These points are very important from the point of view of board exam also. They may ask you to draw the graph and label the points for 2 marks. Stress and strain curve, we call it as. So draw the stress and strain curve, label the points. Label it. Okay. With all these things now, we think of 2 more types of stress and strain, and we'll come back to it. But before that, can you write this? 2 more question. Write stress and strain curve. Write stress and strain curve and label the parts. Write stress and strain curve, label the parts. Write down this graph and label the parts. It's there in the textbook also. Nane kedodeno andre skin falls onto which category? Heart tissues, which falls onto which category? Body, there are some muscles which we call them as elastomers, where stress is not proportional to strain, but they will not fracture with lot of strain also. Doddu strain adrunu, they will not fracture. They will come back after that. They are called as elastomers. We started 2 more stress and strain. In the yesterday's session, we learned longitudinal stress or tensile stress and longitudinal strain. Today, we want to learn 2 more. Shearing stress, shearing strain, volume, compression stress and volume strain to be learned. We start with those things now. If all of you have written it, we start with those things. Okay, go for it now. Say, if we have a big book, if you have a, say, big book like that, size is big, not the area, but thickness. Doddu book idre, you can try this, my dear friends at home. This is the book end. Pages ee kadeyinda open madadide. Idu binding end. Idra mele sumne ನೀವು ಬೇಕಾದ್ರೆ ಪೆನ್ಸಿಲ್ ಅನ್ನು ಮಾರ್ಕ್ ಮಾಡಿ ನೋಡ್ಕೋಬಹುದು. ಹಿಂಗೊಂದು ಪೆನ್ಸಿಲ್ ಅಲ್ಲಿ ಒಂದು ಲೈನ್ ಹೇಳ್ಕೊಡಿ ಮಕ್ಕಳ. ಒಂದು ಲೈನ್ ಹೇಳ್ಕೊಡಿ. ದಪ್ಪ ಬುಕ್ ಮಾಡ್ಬೇಕು, ಡಿಕ್ಷನರಿಗಳೆಲ್ಲ ಇರುತ್ತಲ್ವಾ. ಯು ಅಪ್ಲೈ ಎ ಫೋರ್ಸ್ ಓವರ್ ಹಿಯರ್. ಟ್ಯಾಂಜೆನ್ಷಿಯಲ್ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿ ಮಕ್ಕಳ ಟು ದಿ ಸರ್ಫೇಸ್. ಹೀಗೆ ಹಿಡ್ಕೊಂಡು ತೆಳ್ಳಿ ಅಷ್ಟೇ. ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ಟು ದಿ ಬುಕ್? ಇಟ್ ಚೇಂಜಸ್ ಇಟ್ ಶೇಪ್. ಯಾವ ತರ ಚೇಂಜ್ ಆಗ್ಬೋದು ಶೇಪು ಬರೀತೀನಿ. ಇಟ್ ಬಿಕಮ್ಸ್ ಆಲ್ಮೋಸ್ಟ್ ಪ್ಯಾರಲೋಗ್ರಾಮ್ ಲೈಕ್ ದಿಸ್ ಅಲ್ವಾ. ಈ ತರ ಚೇಂಜ್ ಆಗತ್ತೆ. ಯೂಶುವಲಿ ಐ ಯೂಸ್ ಟು ಡೂ ದಿಸ್ ಥಿಂಗ್ಸ್ ಇನ್ ದಿ ಕ್ಲಾಸ್. ಬಟ್ ಈಗ ನೀವೆಲ್ಲ ಅಲ್ಲಿ ದೂರದಲ್ಲಿದ್ರಿ, ಇಲ್ಲೂ ನಾನು ಬೋರ್ಡ್ ಮುಂದೆ ಲೈವ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಇದ್ದೀನಿ, ಅದನ್ನ ತೋರ್ಸ್ಲಿಕ್ಕೆ ಆಗ್ತಿಲ್ಲ. ಒಂದು ಬುಕ್ ಹಿಡ್ಕೊಂಡು ಹಿಂಗೆ ತೆಳ್ಳದ್ರೆ ಇಟ್ ಬಿಕಮ್ಸ್ ಪ್ಯಾರಲೋಗ್ರಾಮ್ ಲೈಕ್ ದಿಸ್. ಆಗ ನೀವು ಮಾರ್ಕ್ ಮಾಡಿರೋ ಲೈನು ಚೇಂಜ್ ಆಗುತ್ತೆ. ಇಟ್ ಆಲ್ಸೋ ಚೇಂಜಸ್ ಲೈಕ್ ದಿಸ್ ಸ್ಲ್ಯಾಂಟ್. ಇಟ್ ಮೇಕ್ಸ್ ಅನ್ ಆಂಗಲ್ ವಿತ್ ಥೀಟಾ ವಿತ್ ದಿ ಒರಿಜಿನಲ್ ಮಾರ್ಕಿಂಗ್. ಅಂದ್ರೆ ಹೈಟ್ ಎಷ್ಟು, ಇದು ಒರಿಜಿನಲ್ ಮಾರ್ಕಿಂಗ್ ನ ಹೈಟ್ h ಅಂತ ಕರ್ಕೊಂಡ್ರೆ ಅದ್ರ ಜೊತೆಗೆ ಥೀಟಾ ಆಂಗಲ್ ಅಷ್ಟು ಮುಂದೆ ಹೋಗುತ್ತೆ. ವಿ ಕಾಲ್ ದಿಸ್ how much it is pushed forward as x. Observe here. Here, no change in the volume, no change in the length, no change in the area. What is changed there? Only shape. Nothing. No such property, length, area, or volume is changed. Only shape changed. Everything remains same. That's why we call the stress generated here, we call it as shearing stress. Shearing stress. Here the force is tangential. Contrast to the previous tensile stress or longitudinal stress. What is the force there? It is normal to the area there. We showed it for the wire in last session. Here it is tangential to the area. Even though we are applying it like this, the restoring stress starts acting in the opposite direction. That is what we call as shearing stress. How to define it? Shearing stress is the tangential force, restoring force generated per unit area. Tangential restoring force generated per unit area is what we call as shearing stress. You must know the definitions. Then we ask for one. The tangential restoring force generated per unit area. And then corresponding strain, shearing strain. Shearing strain. What do we mean by that? Shearing strain. Shearing strain, change in volume or something cannot be written now. Change in the shape to be written. Change in the shape can be written as tan theta. That is the change in the shape. Or else I simply write tan theta x by h. Or for small angles, it will not make 30-degree change or something like that. Only small angle, or we can simply take theta as x by h. We did this type of approximations many times. This is what we call as shearing strain. Theta equals x by h. Therefore, so shearing stress you know, now shearing strain you know. Shearing strain is x by h or theta angle through which it is. That line mark is bent. Shearing stress you already know. Once you know shearing stress and shearing strain, there's an astonishing fact now coming up. What is that? Say, many of our young friends who are listening to me are very eager about the space adventures and all those things. Can you imagine? We are trying to go to Mars and everywhere. But can you imagine? We have not researched to the deepest part of the ocean. Even today, men cannot reach, the human beings cannot reach the deeper parts of the ocean because of the severe pressure conditions that we learn in the next chapter. But for the time being, severe pressure conditions will be there at the deeper parts of the ocean. Even today, that's why some of the parts and in the ocean, in the deepest parts of the ocean, is not reached by human beings. It's not only human beings, even light will not reach there. Light is moving so much with lot of speed, but it will not reach the deeper parts of the ocean. Almost at very deeper parts, light is zero, no light at all. All those animals who are living there are not dependent on light. Okay, what are you think? That's an extra thing. Curious fact. Now we'll come back. Shearing stress, shearing strain. Why I said that pressure idea? Why I said the deeper parts of the ocean? Because when we dip something into liquid, say water, what will happen? Say I dip some object into the water. We learn about much about these things in the next chapter also. What happens? Can you remember? Why the people cannot go into the deeper parts of the ocean? Because of this, what I am writing now. That object is going to be compressed from all sides equally. At deeper parts, that compression becomes enormous. We will be crushed to point size. We will be crushed to death. That's why we cannot. ಅಲ್ಲಿಗೆ ಈಗ ವಾಟರ್ ಒಳಗೆ ಅಥವಾ ಯಾವುದೇ ಇದ್ರೊಳಗೆ ಹೋದ್ರೆ ಫ್ಲೂಯಿಡ್ ಒಳಗೆ ಹೋದ್ರೆ there's a stress created. ಎಲ್ಲ ಕಡೆ ಎಲ್ಲೋ ಅದನ್ನು ಕ್ರಂಚ್ ಮಾಡುತ್ತೆ. The volume decreases. This type of stress is called as it compresses, we call it as compression stress. We call it as compression stress. What we can think of it? It is the internal restoring force generated, normal internal restoring force, because it always acts normal to the surface. Therefore, the outward force also, restoring force also acting normally. Therefore, normal restoring force per unit area is what we call as compression stress. And observe, for compression stress and longitudinal stress, both are normal forces, normal restoring force. That is, they act normal to the area, except for shearing stress. Okay. What type of strain can be observed? Can you think of? What is going to decrease here? It crunches volume. Volume decreases. Whole volume get crunched. So strain is volume strain we call. Sometimes we also call it as bulk strain. Volume strain or bulk strain we call. Bulk strain we call. What is it? Change in volume by original volume. Change in volume by original volume is bulk strain. We learned two things now, last bit of types of stress and strain. Compression stress, volume strain. Compression stress defined as normal restoring force per unit area. Then volume strain or bulk strain is change in volume, ratio of change in volume to original volume. That is the compression stress. With that, now say stress proportional to strain. If we make it an equation, what we get? We write stress proportional to strain. Unfortunately, no symbols are there. Stress ke sigma upayogisbeku, strain yen symbol illa full level. So if you make it an equation, we introduce E there. E, strain. What is E? It is called as modulus of elasticity. Modulus of elasticity. Modulus of elasticity or elastic modulus. Proportionality constant, it is called as modulus of elasticity or elastic modulus. At once, can somebody among you tell me what is the unit for E? Be fast. Unit for E. Be fast. Definitely. What is the unit of stress? That is the unit of E also, because strain doesn't have any unit. Yavudu unit. Adrinda modulus of elasticity are same unit as stress. Okay, nice. Okay, with that. Now, observe. Few of you may be thinking, where do we use all these things? In fact, because of these properties only, you can listen to the voice. You can listen to the voice or sound. Because of this only many other things are happening. Waves can propagate. Musical instruments can create beautiful sound because of elasticity. It has connections to many things in day-to-day life that we think of later on. Because of this only we can build, say, beautiful houses with cement and other things. Why? How? And because of this only we can build the dams, reservoirs for our crops and other things. So that we think of later on. But for the time being, elastic modulus or modulus of elasticity, here and after I call E, is stress divided by strain. It is defined as ratio of stress to strain. Again, there are three types of stress and three types of strain, therefore three types of elastic modulus. First one, Young's modulus. Young's modulus, denoted by Y, capital Y. It is defined as ratio of tensile stress to the longitudinal strain. Tensile stress to the longitudinal strain. Tensile stress to longitudinal strain. Tensile stress to longitudinal strain. Tensile stress means F by A I can write, force per unit area. Longitudinal strain means delta L by L, what we learned in the last session. Therefore, we can simply write Y as FL by A delta L. FL by A delta L. FL by A delta. This is the first elastic modulus what we are learning. Just here, you may be asked to define like this. Define Young's modulus. One more question. Define Young's modulus. Y-O-U-N-G apostrophe. Define Young's modulus. Define it as ratio of tensile stress to longitudinal strain. Sometimes longitudinal strain is also called as tensile strain, but always write longitudinal strain. So with this, now I conclude this session here.